All right. So today we're going to talk about solving for variables, and then we're going to go ahead and evaluate expressions. So you'll see a little bit of the difference between the two as we progress. So we're going to start with solving for variables. So that is going to be different than evaluating. When you solve for variables in an equation, that's important. It's in an equation. You have an equal sign. You should remember that you would want to distribute when necessary. So if you see parentheses, you'll want to distribute first. And then the general rule is to move variables. So variables like X, Y, Z, those are the most commons, but really any letter. You'll want to move to one side. So it doesn't matter if it's the left side or the right side. And then move all the numbers to the other side. And then you'll use reverse operations to solve. So, for example, if on the side where you have X and you want to get rid of like a number, if you're adding X plus, for example, X plus 2 equals 0, you'll want to subtract. That's the reverse operation on both sides to get rid of this. So that's what you'll do. And if you think about reverse operations or opposite operations, you could also think of multiplication and division as reverse. And then I mentioned another one. So addition and subtraction. These are the two types we're going to focus on today. So let's get to it. Say here, if I were to want to solve for X, of course, that's the variable that we have. Do I have to, one, distribute? Well, no, there's no parentheses. So if I were to look at this, no parentheses. So therefore, no distribution. Next, I want to think about, are all the variables on one side? Okay, well, there's only one variable in this case, and it's on the left side. And on the right side, I only have numbers. So in this situation, variables are on one side, and numbers are on the other. Here, I'm just going to go ahead and simplify. So I have 3x equals 3 plus 9 is 12, right? 3 plus 9, that's this. Now I'll want you to go ahead and pause for a second and think, if here I have multiplication, and in order to solve for a variable, I want to do opposite operation. What do I want to do? So multiplication, the opposite or the reverse operation is division. So I want you to go ahead and solve. So if I'm originally multiplying by 3, if I want x by itself, I'm going to divide by 3. That's going to get rid of this because divided on both sides, 3 divided by 3, if you ever do that, equals 1. So here, you could technically cancel that out and you'll have 1x or just x. For our purposes, we're just going to leave it as x. X equals, what's 12 divided by 3? It's 4. And that's our answer. Okay. Next. Oh, I should have solved in this page, but okay, next. we're asked to go ahead and solve for this. So here, there's a little bit of a difference. So here, we don't have parentheses, no parentheses. But we don't have the variables on one side and the numbers on the other. If you see, this is a number and this is a variable. So we want to make sure we're moving things over. So separate variables. So I'm going to go on to the next page where we're going to go ahead and have a little bit more room. So again, I said we don't have parentheses, so we don't have to distribute, but we don't have all the variables on one side and all the numbers on the other. So what I'm going to do is first go ahead and move the numbers to the right and keep the variables to the left. So here my problem is, this is on the left. The operation I want to do, since this is a -3, is that I'm going to add 3. And remember, what I do to one side, I want to do to the other. So then a -3 and a +3 equals 0. So that cancels out. A 9 and a +3 equals 12. So that's 12. And then we still are left with 3x. And then we still have the equal sign. Okay. So now I made sure that my variable was on one side and my numbers were on the other. So my last step, just like in the previous problem, this should look familiar. If this is 3 multiplied times x, that's what 3x means, equals 12. If I want to get x by itself, I want to do the opposite operation of what it has. So if I have 3x, or 3 times x, then I want to divide by the 3. And we do that on both sides. Remember, everything we do on one side, we do to the other. So then we're left with, again, x equals 12 divided by 3 is 4. Same thing. And as you can imagine, now I have another thing where I do have parentheses. Yes, parentheses. Therefore, I do have to distribute. And then right away also, if I know that when I distribute, I'm going to have a 3 and an x, because 3 times x, that's the first arrow. If you think about these arrows as little rainbows, or those are just distribution arrows. You want to do 3 times the first thing, and then 3 times the second thing, which is -1. 3 times -1 is -3. And then we still have 9 on this side. And if you see again, variables are not all in one side, and numbers are not separate. So they're not on opposite side. So again, if I were to solve this, again, same problem. The first step was to distribute because there was parentheses. So 3 times x is 3x. Then 3 times -1 is -3. Remember, 3 times -1 equals -3. And then we just bring down the 9. This should look similar to what we did up here. We're left with 3x minus 3 equals 9. Okay, same thing. So as you know, again, same example. I have to add 3 because we're doing the opposite, and we want to make sure the variables are one side and numbers are in the other. So if I add on one side, I add to the other. This is 12. This cancels out to be 0. We have an equal sign. And then I still have a 3x. Now, if I want to solve, it's going to be sorry, 3x equals 12. Same thing, 3 times x. Now I want to divide to isolate the x. We do it on both sides. Whatever we do to one, we do to the other. And we have x equals 4. Same problem. But we could see this problem. Again, we get x equals 4, x equals 4, and x equals 4. But sometimes we need to distribute. Sometimes we need to move the variables to the one side, and sometimes we don't. For this problem, if you see the parentheses and the x in the parentheses, you'll know that you do need to distribute. So I see parentheses, therefore I distribute. And then I'll see, once I distribute, that there's going to be numbers and variables on both sides. So I'll want to make sure that they are move all variables to one side and all numbers to other. So let's do this. So I see parentheses, therefore I distribute. Okay. So 2 times x, whenever, okay. And this is just to make a point again. So you should write this down. Whenever you see a number and there's no sign in between it, just a parenthesis, you should automatically assume that it's multiplication. Okay. So I'll say that again. If you see a number and nothing in between the number and the parentheses, you're assuming multiplication, or what multiplication is when there's two things in the parentheses, it's distribution. So always assume multiplication. All right. So if I distribute, I do 2 times x, that's 2x. And then I do 2 times positive 7, that's 2 times 7 is 14, okay? And then I have an equal sign, and then I have a 20. Next, I distribute it. So my next start is to make sure I have variables on one side and numbers on the other. It's easiest for me to go ahead and just move this 14 over. So doing the opposite sign operation, so negative 14. Again, what I do to one side, I do to the other, so negative 14. Positive 14 minus 14 is 0. This cancels. 20 minus 14 is 6. And we have an equal sign right here. That's just dropping from here. And then I still have a 2x. So to write this again, so that you see it again, so 2x. There's nothing there, equals 6. That's this and this. I could solve for x. And now, again, doing the opposite operation of 2 multiplied by x, now I want to divide that 2 to get that x. So 2, 2. Because what I do to one side, I do to the other. This cancels because it's 1, right? 2 divided by 2 is 1. So x equals 6 divided by 2 is 3. That's my answer. So as you see, in all these problems, we've been solving for a variable. We've been solving for x. All right. So now let's extend our thinking a little bit more. I just wrote again here, distribute when necessary. I don't see any parentheses, therefore I don't think we're going to need to distribute, right? And then second step, make sure we move all variables to one side and all numbers to the other. I see an x here, an x here, and an x here. Therefore, there are not all variables on one side and numbers on the other. And when I say one side and the other, I'm talking about to the left or to the right of the equal sign. So here, I see an X and an X on one side. I could right away, if I wanted to start, I could combine the like terms, right? X and X can be combined. What is 3X plus X? Well, that's 4X. Because this technically means just 1X right here. And then I have a -8, so -8. And then I have 2X minus 4. All right, so I simplified it. If I wanted to, I could move this 4X to this left right side, or I could move this 2X to this left side. Since we've been talking about keeping variables to the left, I'm just going to move the 2X to the left. And what I do is now, since this is 2X, then I'm going to do the opposite, which is -2X. And I'm going to do -2X. Again, 4X minus 2X is 2X. We're just looking at the coefficients. 4 minus 2 is 2. Still have a -8. This canceled, so that's 0X. And then I still have a -4. But I still don't have all variables on one side and all numbers on the other. So the next thing I could do is, if I want to keep my variables to the left, then this is in the way. So what I do when this is in the way or this is in the wrong side is I do the opposite operation, like always, right? So if this is -8, then I'm going to add 8. That's the opposite operation. This cancels out to be 0. But again, what I do to one side, I do to the other. So +8. Here, -4 plus 8 is what? It is 4. Ooh. So then I have an equal sign, and then I have this 2X. So this is 2X equals 4. If I want to solve for X, I want to isolate the X. So if this is multiplied by 2, this X is multiplied 2, then I'm going to divide by 2. Reverse operation, right? And I do it on both sides. So then I have X equals 4 divided by 2 is 2. That's my answer. Now, I want you to see it doesn't always have to be X. The variable could be Y, it could be Z, it could be C, it could be K, it could be any letter, right? It's a variable. Variables are letters. And we're solving for that variable. So here, I actually see a parentheses. So I do have to distribute. So I do have to do this. And I see a Y, and a Y, but on both sides of the equal sign. Therefore, I do want to move all variables to one side and all numbers to the other. So if I distribute first, I have 3 times Y is 3Y. 3 times 2 is 6, positive 6, because this is positive. And then I have another 2Y. Have an equal sign, and then I have 36 and a -Y. Right away, you should know combining like terms. I'm combining them only on one side, right? 3Y plus 2Y is 5Y. And then I have a +6, so +6. Everything on this side, the right side, stays the same, 36 minus Y. If you think about why I only combined the right side Y's, the left side Y's, is because they're on the same side of the equation. Do not try and combine the Y's that are on the right side with the Y's that are on the left side. The only way that you're combining those is by doing opposite operations when they're on opposite sides of the equation. So now I have 5y plus 6 equals 36 minus y. So I could get rid of this minus y to be on the left side if I add a y. So plus y, again, that's the opposite operation. A negative y and a positive y equals 0y. So this cancels out. But I have to do that on this side, plus y. That's going to be 6y. I bring down what I have, which are these two. So plus 6 equals 36. Again, I'm left with 6y plus 6 equals 36. Still don't have all numbers on one side, so I'll subtract this 6 and put it on the right side because we said that we want to put the numbers on the right side. And I have 36 minus 6 is 30. Positive 6 minus a 6 is 0. And I still have this 6y. So I'm left with 6y equals 30, but I want to know what y is, not 6y. Therefore, I want to get rid of the 6. And if it's multiplying 6 and y, then I want to divide 6 on both sides. And I'm left with y equals 30 divided by 6 is 5. Okay. Next, you could see these types of examples with word problems. So say a runner or you and your friend are having a race, right? Your friend runs 7 miles per hour and you run 5 miles per hour. Just because you know that you run a little slower, right? 5 miles per hour is slower than 7 miles per hour. You get a 10-mile head start. So think about that. So say a runner runs 7 miles per hour and another runner runs 5 miles per hour, but gets a 10-mile start. At what time will they be the same? Okay. So if you want them to be the same, another word for same is equal. So when will 7 miles per hour equal 5 miles per hour plus the head start plus 10 miles? So here we could substitute this. If we think about this, this is basically our variable, miles per hour. So I'm just going to do this as, I don't know, hours. So I'm going to put 7h equals 5h plus 10 miles, which we're not even going to put units for that. What I want to do now is solve for h. At what time? Hours, right? That's what h is. Will they be the same? Will they be equal? So we have to solve for h, and we know how to solve for h. We've seen this. It's basically what we just did. We have h's on both sides, but we want to make sure that we have them on one side and we solve for that one h. So I have a 10 on this side, but I also have a variable h on this side. If I want to move them, I'll go ahead and move this 5h to the left. And by doing so, I subtract 5h on each side. And that gives me 2h. And then this is 0, but this is plus 10. So if I were to solve now, I have 2 multiplied by h equals 10. I'll divide by 2 on both sides. And I'll get h equals 10 divided by 2 is 5. At h equals 5, they will be at the same point. All right. So if you want, take a little break, take a breather. And remember, so far, we have solved for a variable here, 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 and up here, right? We've solved for variables. You get the point, right? Now, if we think about evaluating expressions, we know what the value of the variable is, and we're just going to plug it in. All right. So when we're solving for x or solving for a variable, we do not know what the variable equals or what the variable's value is. When we are evaluating, we know the value of the variable, and we're plugging in that value to be able to draw conclusions. So usually this comes in the form of expressions. So if you think about an expression could be 5 times x plus 5. That's an expression. An equation, x plus 5 equals 2. There's an equal sign. So this is an equation, and this is an expression. If you look at the word even equation, it starts with the equal root word. So you should know that there's going to be an equal sign when you're talking about equations. So let's practice. Evaluate. So that means plug in, right, with an expression. What is 5m minus 6 when m is 7? So if m is 7, all that means is that every time we see an m, we're going to put a 7 there. So if I have 5m, and we said m is 7, we'll put a 7 right there. So 5 times 7 is 35. And then we have a minus 6. 35 minus 6 is 29. So when we're evaluating, we get an answer too. So the answer to a question where it would say, what is the value of the expression when 5m minus 6 when m is 7? And then we could do the same thing for multiple variables, and we are evaluating. So I'll color coordinate this. So if you have 5t plus 2m, what's the value when m is 7 and t is 2? So m is 7, t is 2. And I have a t right here and an m right here. So I want to put this 7 in here and this 2 right here. So I have 5, t is 2, plus 2, and m is 7. And then I'm solving, so that equals 5 times 2 is 10. That's this. Plus 2 times 7 is 14. Therefore, my value is 24. That's what I get when I solve or evaluate for this. All right. And again, we could use these types of problems to evaluate for different expressions given like word problems. So let's say you're doing a walkathon and you have a sponsor, and he's committed to give you a flat fee of $5 plus $2 for every mile m you walk. So flat fee and $2 for every mile m you walk. How much would your sponsor give you if you walk 20 miles? All right, so let's forget about the 20 miles. First, let's see what expression. Remember, here we're given expressions, and then we're given a value to be able to put it in. So my first step should always be come up with an expression. Whenever you're giving it a word problem, you first want to come up with an expression. So take a minute and write these 2 steps down for evaluating expressions with word problems. That's what you should head it. And then step 1, come up with an expression. So if I were to do this step first, I read this problem and I see, okay, so he has committed to give me a flat fee of $5. So that means a flat fee is that regardless of how much I walk or I run, he's giving me $5. And then for every mile, he gives me $2. So if I think about this, regardless, I'm getting $5. And then $2 is a rate. You're going to be introduced a little bit more to rates. Right? We've done something like this. If you think about the problem I gave you about apples, Mary selling apples for 50 cents and then a $3 delivery rate or flat rate. This is basically that flat rate. Okay. But if you continue reading, plus $2 for every mile M, here I'm getting $2 for every dollar M. Whenever you see for every mile or for every so often, it's giving you a rate. Those words should scream out rate. That's a rate. Therefore, it has to be attached to a variable. So I came up with this expression. I have 5 plus 2m, or 2m plus 5, whatever you want to think about it. So I like to have my variables first. So I'm just going to rewrite it down here. 2m equal plus 5. So now I want to evaluate the second part. How much would my sponsor give me if I walk 20 miles? Remember, here, miles was defined with m. Therefore, this is m. So I could go ahead and plug it in just like I did up there. But now it's 20. So if I evaluate this expression, I have 2 times 20 miles plus the $5 he has guaranteed to give me. And that gives me 2 times 20 is 40, plus the $5 he's guaranteeing to give me is 45. And this is how I solve for how much my sponsor will give me if I were to have walked 20 miles. Okay. We'll practice more in class, okay?